Good morning everyone. So in this section we are going to learn about power supplies. You people know that each and every circuit needs some DC power supply. Okay? That DC power supply we are going to learn in today's class. Do you know what is DC power supply? It's a directional current. It will be having a direction. That means positive and negative. So generally we will be getting here in our households AC. AC we will be getting in our socket 230 volts, 50 hertz. Now our job is to convert this 230 volts AC into our required DC supplies. In general we will be using circuits with 5 volts or 12 volts DC. 5 volts or 12 volts DC in our regular circuits. Mostly we will go for 5 volts. Now I am going to explain you how this 5 volts can be designed from this 230 volts AC. Again block diagram. See. So first block is source. This is source. Second, step down process. Step down process. Next, rectification. Rectification. Next, filter. Next, regulator. Output. This is the basic block diagram of a general purpose DC power supply. So if you observe again, first AC source, that means 230 volts AC. This 230 volts AC will be stepped down by using a step down transformer. Later that step down transformer output will be rectified by rectification process, then it will be filtered, then it will be regulated. That's the output. So this is the block diagram. I hope you understood this block diagram. Now circuit diagram. So we are having 230 volts AC source. Here I am using a step down transformer. I am using a center tapped step down transformer. Students, please be specific what kind of transformer you are using. Whether it's a single coil transformer or 2 coils, that is step down, 2 coils, and center tapped. So if you see the coil, primary winding will be like this, and secondary you will find 2 coils like this. And this is the center one 0. If it is 12, 12, 0, 12. This is center tap transformer. And this is the AC source. So here I selected a center tap transformer. Now, when you are speaking about any component, you need to be specific about its parameters. So here transistor parameters are 230 volts AC and secondary will be 12, 0, 12, 1 ampere. So this is rating we call. So transformer rating will be 230 volts AC primary, 12, 0, 12, 1 amp secondary. So this is step down transformer. Here I will be getting 12 volts AC. So the transformer output will be 12 volts AC from this 230 volts AC. Now after this I am going to add diodes. This is the rectification process, and in rectification we will be discussing generally three kinds of rectifications: half wave, full wave and bridge rectifications. Here I am using full wave rectification. So assignment for you: what is meant by half wave, what is meant by bridge. So that things you have to write in your notebook. Those things are assignment for you. So here I am using full wave rectification. For that I am using diodes. So this is the symbol for the diode, and this line, whatever this is the cathode part, this is the anode part. So this is symbol for a diode. So I am combining two diodes, and center point will be the minus. I am connecting a filter capacitor here. So this is the filter. Now values will be 1N4007. Here also 1N4007. So these two are the diodes. It's general purpose PN junction diodes. Now in Google you have to search data about these diodes. Why I selected IN4007, and you also collect the data, some theory about diodes, PN junction diodes, and the filter capacitor value will be 1000 microfarads, 25 volts. So now your assignment is, you have to tell me how I selected these values. When you come across these capacitors, we can find 470 microfarads, 500 microfarads, 750 microfarads. I selected 1000 microfarads. So you have to answer why I selected this 1000 microfarads capacitor in this circuit. So that's your assignment. Now we finished step down, we finished the rectification, we finished the filter. Now the regulator part. We are using a voltage regulator numbered as 7805 for 5 volts. If you want 12 volts, we can add 78012, 7812. It will be between the 12 volts. If you want 9 volts, you can connect 7809. You will be getting the 9 volts. So I hope that you learned in your regular classes about these regulators. We call 78XX, we call 78XX. So 78 will be some company code, will leave it. These XX will be the voltage. If you find 05, it will be the 5 volts. If it is 06, it will be 6 volts. So last two digits shows the voltage of that regulator. Okay. So we will be having another kind of regulator, that is 79 series. That will come later in our classes. Right now you just focus 7-8 only. We have different kinds, positive and negative. Those I will be telling later. Right now you just focus this, because we are going to use these circuits in our projects. After regulation, this is the output. And you can connect an LED for indication at the input level. Connect an resistor and LED. Last night one student asked me, again I am saying, LED voltage will be 1.5 to 3 or 3.5. It depends on the color. If you are using red color, you will be having a different voltage. Green color, another voltage, like that. So whichever color you are selecting, you need to calculate according to that LED's voltage. It's input voltage minus, here I am writing, input voltage minus LED voltage by LED current. That is R is equal to. It's nothing but Ohm's law only. If you are applying 12 volts, it's 12 minus 1.5 by 0.2 amps. That is the answer. R is equal to. So that value you have to connect to this LED. So this is the outline of the power supply. I hope you understood this.